Alright, so we're going to follow the guide on building your head's firmware from scratch. And this will require us to compile it via Docker. So what we'll do is open up a terminal and then cd into your project directory. Alright, so what we're going to do is so the first thing we got to do to get our head's firmware is we have two options. We can compile our own firmware, or we can download precompiled firmware. So let's go to the head's website. And these are all the latest commits as of the last 5 days ago. So what we'll do is ideally what the head team recommends is finding a commit that's roughly around maybe a week back, just in case there's anything wrong with the most recent commits. There's two things we need to look for. We need to make sure that the commit was verified, which means that the commit was signed and that there was a green check mark. The green check mark will mean that the build that went on in the back end was successful. So we'll click right here. And then what we'll do is take note of the commit. What we'll do is take notice of this commit hash right here. This is just a section of it. So for this example, what we're going to do is we're going to actually go and compile and build our head's firmware from scratch. So what we'll do is, following the instructions, we'll go open up the terminal. We'll go into our directory where our head's guide repo lives. This is not completely necessary, but that's where I'm going to work out of. And then what we're going to do is start up a Docker container of Debian 11. And if the Debian 11 Docker image doesn't already exist, it's going to go and download it, which it has here. And what it's going to do is it's going to download the Debian 11 image if it's not already installed, and it will then put you inside the image, or inside the container. So we're now inside the Debian 11 container. You get our host name, see we're actually indeed in the container. We open up another tab and do a Docker PS. You can see that image is running. So if I go back to this tab, so now we're going to run the following commands, and this is in the documentation. So we're going to do a apt update, and then what we're going to do is do an apt install, and there's going to be several packages in here, so just copy and paste what's from the guide and let that run. It's going to take about a minute. Alright, and then what we're going to do is clone the main heads repository onto the Docker container. And then we're going to cd into the heads directory. And then what we're going to do is take this commit, this shortened commit hash, copy it, and then we're going to run a git switch -c for the commit, and then paste that in. And now that's switched us to the branch that's based off this commit. That's based off the one that we picked over here. So what we'll do is continue running the rest of the commands. So what I'll do is I'll just copy and paste the following. Alright, and then what we're going to do is we're going to run the final command that's going to actually do the compiling. And this will take about 5 to 10 minutes. Alright, once you get to this output, everything should be compiled correctly. A few things that we want to note is these hashes that are present on the screen. So if we open this up, we'll kind of divide this a little bit better. But what we do is we have the hash and the corresponding file name that goes with it in the directory path that's in. So we want to focus on ones that end in dash top and one that ends in dash bottom. This will be the images or the ROMs for the top chip and the ROMs for the bottom chip. So what we need to do is we have to get the files from our Docker container onto our host system. So what we'll do is we'll open up another tab in our terminal and make sure that we're in a directory we want to dump these files onto. So I'm in our heads guide directory, so I'm going to dump them here. What we want to do is we can run docker ps to get that container ID one more time, and we will run docker cp, which stands for copy. We're going to copy this docker image ID, paste that there, then a colon, and then the path of the ROMs that we want to copy over. So we have the top ROM. We'll paste that in, and then we'll put a dot that will tell this to drop the file into the current working directory. So we're going to do that, and then what we'll do is we're just going to go back and replace top with bottom and hit enter. And if we do a ls, we'll see we have those two files in our working directory. So now you can jump over to the flashing via the programmer section of the guide, but for now we are going to focus on the alternative method of getting the firmware, which is downloading the pre-compiled firmware from GitHub. So to do that, we'll put this aside and we'll go back to this page that we chose for grabbing the commit that we want to focus on. So what we can do is we can go up here to this green little check mark, which tells us that the build was successful. And we're going to click on it, and then what we'll do is we'll have all these different builds that went on by CircleCI, which is like a DevOps pipeline. And we're going to scroll down to the X230, and we're going to look for the X230 HOTP maximized. And we're going to hit details. So now we're in the CircleCI dashboard, and pretty much every time a commit is ran, it will run this build process that will test and check the code and then build out the ROMs. So what we can do is go over to Makeboard, and then what we're going to do is look for the checksums that are related to the bottom and the top ROM. So we scroll down here and we have this bottom ROM, sorry, this top ROM, we have this bottom ROM. So we're just going to take note of those. And then what we're going to do is going to scroll up to artifacts, which is at the top up here. We're going to find the bottom and the top ROM files. So what we'll do is we'll save those. All right, and we're going to save them into our heads guide directory for now. This doesn't really matter, but this is the directory we're going to work out for this demo. So we're going to hit save, and then we're going to right click, save link as. We're going to click here, oops, right click and hit save link as, and save that. So what we'll do is we're going to go back to the make board and notate these the files that we're looking for. And we're going to open back up our terminal, clear this, and what we're going to do is we're going to run echo, and we are going to start with the top ROM. So what we're going to do is go over here to the left and copy the hash for the top ROM. Go back to our terminal, paste in that hash, and then put in the file name we want to test. So if we hit tab twice, we should see the top ROM right here. We're going to right click and hit copy. Make quotes around that. And then we're going to do a SHA-256 sum -- check. And if we get this OK, this means that the checksum matched the checksum for the file, which means that nothing's been altered. So we'll do the same thing for the bottom ROM. So we'll go back over here, look for the bottom ROM, copy the hash, go back to the terminal, and then get our file name, which was right up here. Put a quote around that, pipe SHA-256 sum -- check. You can see that that file was verified as well. And that's pretty much it. The next step will be going to the flashing via programmer section, and we'll move on to that. Alright, so now this step will focus on showing you how to flash the ROMs to the BIOS chips themselves. So here's our X230 Lenovo Thinkpad laptop, and we do need to open it up. In order to open it up, you will have different markings on here. There are some screws that you do need to remove. So flipping this upside down, we want to make sure that the battery is removed and that the power is removed. And then there's two screws. There's this screw and this screw. You need to have those removed in order to remove the keyboard. What we'll do is we'll flip this over, open it up, and this is, I've already unscrewed this. So what we do is you will remove the keyboard and pull out the ribbon from this connector here. And then we have this palm rest, which can be removed. And there's a little clip right here you can pop open and remove it like that. So now this is what's underneath the keyboard and palm rest, and there is some black like a sticker plastic that can be peeled up from this side to reveal these two chips right here. And I'll show this at a different angle. Alright, so here's a different angle right here. And what we did is we removed the keyboard and trackpad, or palm rest, and then there's this black plastic kind of protecting layer, and you have to come back over here and you have to peel back. It's really sticky, and you'll expose these two chips right here. So here's the programmer that you'll be using, and here is the actual clip itself. This clip we're using is the recommended SOIC clip by Pomona is the brand, and it's for a SOIC 8 setup, which is the chips that we'll be working off of. And note the color of the wires don't really matter, but for this example, it could kind of help. Looking at this system here, this is a it's got this little lever that locks in the clips here, and these are just standard male clips that are in here. So you can just shove them in these little holes. And what you do is you'll shove them in these little holes, and then you push back that lever, and then they'll hold it in place. I'll pull these out and give you an example of how this works. So you can see that there's this little black divider right here, and you have 4 holes on this side and 4 holes on this side, and you have 4 holes up here and 4 holes up here. That gives you 16 like input slots. But for this, if you look at the back side, this actually shows you the pinouts for a BIOS chip. So what we'll do is we'll flip back over here, and we'll focus on this side of the board. And we have, starting from left to right, we have slot number 1, 2, 3, 4, then up here 5, 6, 7, 8. And those will correspond to the pins on the clip as well. If we pull this out, you'll see that these have little pins on them that the male and female connectors can go into. So we'll wire this back up. All right, so I'll show you the pinouts on here again. So pay attention, we have on here in slot 1 is black, 2 is brown, red is 3, and orange is 4. So on the clip itself, we have black on slot 1, brown on slot 2, red on slot 3, and orange in slot 4. And then we come over here, we have yellow, green, blue, purple on slots 5, 6, 7, 8. And the same goes over here. We got yellow, green, blue, and purple. And I apologize, I'm holding this with one hand. So that's pretty much the pin setup you have. If you have a set from like Amazon that already has everything wired in and connected, you don't really have to worry about this too much, but this just kind of gives you a basic idea of how the orientation works with the programmer and the clip. So let's get this plugged into the computer. All right, we'll peel this back, and we'll show angles, show this from other angles as well. So what we're gonna do is we have our programmer here, and then we have a USB male to female cable here. We'll plug this into the computer. Okay, and what we'll do is we'll plug the programmer in to the cable that's plugged into the computer. We have a light on, so we see that it is enabled. And what we'll do is we'll take this clip and connect it to this top pin here. So remember in the example on here, black is pin 1, and if we look at the chip here, there'll be a little dot you can see that notates chip 1. So we want to line those up. So what we'll do is take this clip and clip it on just like that. And I'll show this at a different angle. So here we go from another angle. We have the clip in my hand with the programmer, and we have it plugged in. What we're going to do is we are going to come over here and clip that into the board, onto the chip itself. So we just want to make sure it's flush, and what we're going to do is we're going to go back to the computer, and we're going to check to see if the connection was made successfully. All right, so we're back on the computer now. So what we do need to do is, if you don't have it installed, you need to install the program called flash ROM, you can do a sudo apt install flash ROM, and that will install. I already have it installed, so we'll skip this step. And what we're going to do is I'm going to copy and paste some commands from our guide. And now if our system detects, or if the programmer detects the chip, it will show up when we hit this command. This command just pretty much checks to see if the chip is detected by the programmer. And I gotta put in my password. So if you don't get a response back, it could mean that the connector didn't make good contact. So we're just gonna try this again. We'll see it didn't make contact. So what we'll do is we'll take the connector off and reapply it. Well, we're just gonna take a visual peek and make sure everything is connected as it should be. And bingo, we now have a response. So these are possible chips that are found on the board itself. So what we need to do is go to the website for the heads website, and here it is right here. So we're on the guide for flashing the X230 ROMs, and we are going to go here and look. When scrolling from the top down to here, there is this chart of possible chips that the X230 will have. So what we'll do is we're going to come over here and just copy one at a time, and do a search on here to see if it shows up. So this one didn't. Come over here, copy, and paste it in. This one didn't show up either. We'll try this one right here, copy, and paste it in. And bingo, we did see that this chip is one of the 4 megabyte chips that are on here. So we do have a match. So we're just going to notate this chip. And then what we're going to do is come in here, and what we need to do is we're going to read and make a backup of our existing chip firmware that's on there. So we're going to do a sudo flash rom -r. R means read. And what we're going to do is going to name the file, the backup file for this chip. So we're connected to the top chip, so we're just going to call this top backup .rom. Or .bin. And then what we'll do is put in our -- programmer for the programmer type that we're using, -c, and put in that chipset model number that we found that matched the website. And then we're going to do a and then we're going to paste in sudo flash -v, and then what we're going to do is we're going to give it the same bin. And I'll explain what this is going to do in a minute. And then what we'll do is we'll just copy this, paste it in. And what this will do is it will read the chip what this will do is it's going to read the chip, and it's going to save the output, or the pretty much like the image copy to the directory that you're working in, which I'm in my heads guide directory, and it's going to then verify that it was successfully downloaded. So we're going to hit enter, and this takes about a minute or two. So what it's doing is reading the flash. It's going to read it, it's going to copy it, it's going to pretty much dump the data from the flash locally, and then it's going to go and read it again and verify that what was downloaded was actually correct. Okay, and if you get verifying flash ... verify, that means it was successfully verified. And if we do it ls, we can see that the file we called top backup.bin was saved to our system, and this file here is the backup of our existing firmware that we can use to restore later on. So now what we want to do is we want to flash the head's top firmware image to the top chip. So what we're going to do is copy this over. So this is going to be flash ROM, the programmer type that we're using, the chipset that we discovered that we're using, and then a -W, and this is going to be for writing the firmware that we either downloaded or compiled onto the chip. So we'll give it heads 230, and then we're going to do top. So this is the file that we downloaded, and then what we're going to do is we're going to hit enter, and this is going to directly flash the content straight onto the chip, and it will do a verification at the very end. Sometimes you may get errors like this where we see that the erase failed. If this happens, you can just repeat the flashing again. Just the same command. So what we can do is we can just do Control-C to exit out of here. And then what we're going to do is we're going to make sure that the connector is connected to the chip correctly. So we're going to go up and we're going to rerun this. And if we don't get a response back with the name of the chips, like we did earlier, the connector might have slightly moved off course on the chip, and we just need to readjust it. So what we're going to do is we're going to just reconnect it. And then we're going to rerun that command again. And we're getting a failure. These things are very sensitive. Sometimes it's even worth disconnecting your programmer from your computer and reconnecting it. And we can see that we did get a successful connection again. So we're going to go back up to the command that we tried earlier, where we're trying to write the top heads ROM to the top chip, and we're just going to hit enter. All right, so we see that we're getting a flash verification. So it means that the chip was actually flashed. Now it's actually doing the verification of it. And we got the verifying flash verified signal, which means that everything was good. And so the top flash, the top chip has been flashed successfully, and now we can move on to the bottom chip. So just like before, we're going to take the clip here, and we're going to move it from the top, and we're going to move it onto the bottom. Make sure it's on there good. And then we're going to go back to the terminal and see if we got connection. Alright, so we are connected to the bottom chip now, and we are going to run the command to check to see if we're connected, which apparently we are not. So if this is the case, don't forget, try reconnecting it, and if that doesn't work, just unplug and replug in your programmer. Alright, we are connected. So what we'll do is this bottom chip will be a different chip than the top chip. So let's grab one of these and see if it matches the results from their website. So we're going to just do a paste on the find, and looks like this is the Micronix megabyte chip, which is perfect. So we're just going to notate that right here. This is the correct chip. And we're going to do the same steps where we're going to make a backup of the bottom chip, and then we're going to do a verification of it. So let's do that. So I'm going to paste this in. I'm going to give it the name, so bottom backup dot bin, and then we are going to paste in the programmer details and the chip details, and then we're going to put in the information for the verification stage. So, Alright, so we have in the details for reading the ROM and saving it to the system, and we have the verification stage as well. So we're going to let that read the flash and then do the verification. Okay, so we see that the flashing of the bottom, or the backup of the bottom chip has been successful and it's been verified. So now we're going to move on to flashing the heads firmware onto the bottom chip. So we're going to copy the following and then put in the name of the bottom chip, the ROM, and what this is going to do, just like for the top chip, it's going to write the heads firmware onto the bottom chip, and then it's going to do a verification automatically as well. So we're going to run that. Okay, we got verified. So we have now the top and bottom chips flashed with heads firmware. So now the next step is to boot up the system and see if everything worked. Alright, we are back at the system, and let's see if it boots on. Turn the power on. Give it a second. Oh, and that's what we want to see. If you're getting the screen, that means that everything did work, and we can proceed to the next section in regards to setting up your keys. Okay, so we're zoomed in on the screen, and what we're going to do is we need to have a couple of different devices. So the first device that we're going to need is our NitroKey. You can use a NitroKey Storage 2 or a NitroKey Pro. So what we'll do is we'll take this and we'll plug it in. It doesn't really matter which port you plug it into. We'll plug that in. And also we're going to take a regular standard flash drive. Doesn't really matter what size it is, maybe recommended 8 gigabytes and up, but it needs to be FAT32. It needs to be flashed to FAT32 or wiped. It needs to be wiped and partitioned to FAT32. So what we'll do is we're going to take that and plug it into another available USB slot, and then we'll proceed to follow the steps in the guide. So for this, we're going to show you how to set up heads on a system that already has the operating system installed. So we have a so what we'll do is we'll start with so we have the NitroKey and the secondary USB stick plugged in. On this first screen, you can see we get this GPG keyring empty error, which is normal. What we need to do is first we have to go set the time on here to make sure the time is correct. Time is very important for the TOTP feature to work. So what we're going to do is we're going to go down here to exit to recovery shell, and we are going to get this command line. And what you should do is open up a screen on another computer and get pull up the current UTC time. So I got that pulled up. So what we're going to do now is type in the following command. It's going to be date-s and then the year. And then the hour in UTC. The minute. I'm going to do this at about a minute ahead so I can have it prepped up when I click OK. And I'll set this up. I'm going to do and HW clock -W. And then once you have this in, just make sure everything's good. And ideally, you want this to be as precise as possible. So exactly 1:37, 30 seconds. I'm going to hit enter, which is right about now. So here we go. So now we have the time set. We will now reboot. Okay, the system's back online. And now what we got to do is go to the OEM factory reset and re-ownership. So select that, hit enter. And in this screen, just hit continue. And then for these couple questions you're going to get, you're want to push select either yes or no. Just follow along if you want to do it the way that I'm setting it up. So what we're going to do is we're going to hit no for this. We're going to hit no for this. And we're going to hit no for this. And now we are going to type in Y for this, because we want to set distinct pins and passwords for the system. And these will be important pins and passwords you want to save down. You want to make sure that they're secure and they're long. For this example, I'm going to make it really easy just to remember, but you want something a lot more secure than this. So for this example, I'm just going to do password 123 for the example. Okay. And then this is going to be the admin pin. And when you set this, the next two questions, the admin pin and the user pin, whatever you set is going to become the new admin and user pin for your NitroKey. So something to keep aware of. Another thing to keep aware of is once you run this, your NitroKey will be wiped. So be sure to make a backup of it if you have anything critical that's on it. So I'm just going to set this. Do something easy for us to remember just for now for this demo. Okay, and it's going to ask us to set some custom user information for our GPG key. We can hit yes, and we'll type in our name. Put in your name, your email, and then a comment, whatever it is to make this easy to remember. So I'll just put in security key, and enter. It's going to ask us if we want to save the public key to the USB drive. This is highly recommended, so you have a backup of that. So hit Y. It's going to go scan for the drive. I have my drive. It's called 8 gigabyte USB. I'm going to hit enter. It's going to save a copy of the public key to that USB drive. And now it's going to reset the TPM. It's going to reset the TPM. It's going to reset your NitroKey, aka the GPG key that's on it. This is going to take anywhere from 5 to 10 to 15 minutes, so we'll just kind of put a pause here. Alright, once it's done, you'll get to this screen. Be sure to save these pins and passwords for later. Now we'll move on to the next section. We'll hit enter here. And then we'll get prompted to reboot. We'll hit enter there. We'll let the system reboot. Okay, so everything went good. You'll be back from this screen. If you get this TOTP generation failed error, that is normal. We'll proceed to the next section. One thing to note is we want to unplug our NitroKey from the system and then reinsert it back in. Okay, now we're going to hit generate new HOTP and TOTP secret. So you get prompted that this will erase the old secret. Hit yes. Alright, now you can take a scan this QR code or take note of the URL to save your TOTP secret. This will allow you to manually verify that your system hasn't been tampered with. If you don't have your NitroKey with you, go ahead and hit enter, and what it's going to do is going to program the HOTP settings on the USB key. You hit enter and it's going to program the HOTP settings onto the NitroKey. Put in the admin pin that we set earlier. Hit enter. And hit enter again. Okay, now what we'll do is go to options and go to update checksums and sign all files in /boot and hit enter. Hit yes. And then now hit yes to confirm. This is going to verify your GPG key is inserted properly. Now put in your user pin. Hit enter. Okay. So now we're going to go to default boot. And all these verified signatures means that we did everything right. Now the system will boot up into whatever operating system you have. There are some additional steps in my guide. So if you don't get to this screen, just follow the steps for setting up your default boot. There might be some additional things. It should be covered in the documentation. Now we'll proceed on to how to set up heads with no prior operating system installed or on a new fresh install. One thing we will want to do too is we can turn off the system and let's verify that everything is working as expected. So we'll boot the system up. And one thing to note is we want to look at when the system boots up, we want to see that it is verified on the screen and that your NitroKey flashes green, that the system hasn't been tampered with. So right now the USB stick is flashing green. I'll kind of see if I can show that real quick. So we can see the NitroKey right there, flashing green, means that the system has been tampered with. Up at the top we have HOTP, shows success, and that's part of the validation that the NitroKey helps with. Also too, if you don't have your NitroKey, you can do a manual verification with the HOTP code right there, and that should match whatever is on your phone if you say that correctly. If your TOTP code matches and your HOTP shows a success, that means that heads have been successfully set up and it should be working properly. Alright guys, so now I'm going to show you guys how to set up your security keys on heads without a OS installed So in these steps, we will go about installing the operating system onto the system. For this example, we're going to install QubesOS. So be sure to have a FAT32 USB stick. Be sure to have a X230 USB stick set up with Qubes ISO and the Qubes signature file that comes packaged with the ISO dropped onto the root of the USB stick. If you don't have that, you can just install the ISO directly to the USB stick, just like you would with any live USB. So what we'll do is we'll boot up the Lenovo X230. So for this, we're going to need a couple dangs. Alright, as you can see, we got heads set up correctly. Means the flashing did go properly. For this example, to get the everything set up, you're going to need your NitroKey. That could be the NitroKey storage or the NitroKey Pro. You're going to need a empty USB stick, flash with FAT32, and your operating system USB stick as well. Luckily, the X230's got 3 USB slots, so we can utilize all those. So we'll get those all plugged in. Okay, and the first thing we're going to need to do is set up the date and time on the system. So we're going to go down to Exit to Recovery Shell, and then we will need to get the latest time in UTC format. So what we're going to do is we're going to run the type in date -S to the year, the month, the date, and the hour in UTC. We're just going to put this a little bit ahead, so when I click enter, it will be the exact time. Okay, should be formatted like that. I'm going to hit enter, and that's now set. Now we're going to reboot. Okay, so now we're back on this screen. This is normal. What we're going to do is we are going to add the GPG key to our BIOS. So what we'll do is click right here. And then we're going to click on add a GPG key to running BIOS and reflash. And now we're going to hit yes. Okay, we're going to pick the USB stick that's got our Qubes master signing key on it. So here's the master signing key. And the whole point is to get have the master signing key added to the BIOS, so when we go to install the OS, it can do a validation of the Qubes signature file against the Qubes ISO to make sure everything's intact and nothing's been tampered with. So we're going to hit yes to reflash the BIOS, and this will embed that master signing key into the BIOS. Okay, and then we're going to hit yes to reboot. Oh, now we're actually going to hit no to not reboot. I'm gonna hit no to not flash. Alright, so we're going to hit ignore and go to main menu. And what we're going to do is go to options, and then boot options, then USB boot. And this is so we can boot into Qubes. Now we're going to go to the USB stick that has the Qubes ISO on it. Hit enter. Choose the ISO. We can see right here that's verifying the ISO. And I'll be doing that against the signature file with the Qubes master signing keys. Okay, we can see right here that the signature was good. And then what we're going to do is select option number 7 to install QubesOS using the kernel latest. We're going to hit yes. Okay, now this is going to boot up into the USB boot environment based on QubesOS. So now we're just going to install Qubes like normal. So we're going to click continue. We're going to set the installation destination. We are going to have the drive encrypted, so we want that checked. And then we're going to ask for the passphrase to decrypt the disk. Okay, and then we're going to hit save. And we'll hit this to reclaim the space. This is only click this if you know the disk can be completely wiped. And delete all existing. Okay, now we're going to go and create a user. Okay, now we're going to hit done. Alright, now we're going to hit begin to install. And now we're just going to install it like normal. This will take a few minutes. We'll come right back. Okay, once you get to this screen, that means the install is completed, and now we can reboot. Okay, so now if we end up on this screen, that is normal. What we'll do is we'll go to ignore and continue to main menu. And then what we'll do is we'll proceed to options. And then down to OEM, reset and reownership. Then hit that, hit continue. If you get a measured integrity report error or warning like you see here, just ignore it and hit OK. And now we're going to be asked a couple questions. The first 3 questions we're going to put in for no. And then when it asks you for setting up distinct pins and passwords, hit Y for yes. And then we're going to set the a couple different pins and passwords. Make sure these are strong pins and passwords, and you have them saved somewhere. For this example, I'm just going to make them real easy for us to remember. And just a note that once we get past this screen, this will actually wipe your only key and set that these pins, the admin pin and the user pin, to become your NitroKeys, admin and user pin. So be sure to make a backup if you have anything important on your NitroKey. So I'm going to hit enter. It's going to ask us if we want to set custom user information on our GPG key. We're going to hit Y for yes. Put in your name, email address, and then a comment, which we'll put, just type in security key for us to remember what this GPG key is going to be used for. Hit enter. It's going to ask us if we want to save the public key of our GPG key to a USB drive. We're going to hit Y. And then we're going to go look for the formatted USB stick and hit enter. And this process is going to take anywhere from 5 to 15 minutes. This is going to wipe your NitroKey, and it's going to set up everything in the back end. So we'll resume in just a few minutes. Alright, if you get to this screen, that means that your only key has been provisioned successfully. Make sure you save your passwords and pins somewhere safe. Hit enter. Hit enter. Okay, if you get back to this screen, that means that everything was successful. What we're going to do is we're going to unplug the NitroKey and then replug it back in. And what we're going to do is what we'll do now is go to generate new HOTP key. You can hit enter. If you're not on the screen, you can go to the main menu. And then you can go to options, go to TPM, TOTP, HOTP options, and then go to the same thing, generate new TOTP, HOTP secret. Okay. Be sure to take a copy of this this key down, or take a picture of the QR code with some sort of TOTP application like Google Authenticator, Authy, whichever other ones that are out there. make sure your NitroKey is inserted and hit enter. And this will configure the HOTP settings on the NitroKey. Plug in the admin key password on there, PIN, enter. And then hit enter again. Now what we'll do is we're going to update the checksums and sign the files in boot. So we're going to go to options. And we're going to select update checksums and sign all files in boot. Hit yes. We're going to confirm that the GPG key is inserted. Hit Y. Enter your user PIN. Enter. If you do get this error decryption failure TPM unsealed, you can reboot the system to see if it refreshes. You can also try refresh TOTP or HTTP. And that's exactly what we want to see. And also the NitroKey will flash in this state that the system has been tampered with. So if we actually refresh it one more time, or if we reboot the system, if we look at the NitroKey, we'll give it a second. So we see it's flashing, and we see up here that everything says success. And if you don't have your NitroKey with you, you can pull out your phone and compare the TOTP value with what's on your phone. And that's why it's important to have an accurate time set on the system. So what we'll do now is go to default boot, hit enter, and the system will boot up properly if everything was set up correctly. If you do get asked more questions, please look at the documentation. There are some additional steps you can follow to be sure you provide the correct information to the questions. But if you get to this screen, everything should be good. We can test to make sure everything's good just by putting in our decryption key. If you made it this far, that means everything is set up correctly. Thanks everybody for watching this.